Greetings, I'm John the Spirit, I'm electrolyzing redstone for chrome, and welcome to new Omnifactory Supershorts. You could just hear the mirthful smile in my voice as I said that I was doing something so atrocious and horrible and long-taking. Anyway, hopefully this is a one-time thing. Chrome is a crucial component in stainless steel, and stainless steel is used for a lot of HV machines. Chrome dust comes from ruby processing, particularly electrolysis of ruby dust, and you can get ruby dust either from ruby processing or from redstone electrolysis. Now this is obviously a very long process. Not only is it amazingly long, it is also extremely inefficient. It takes 60 redstone to make 1 chrome dust. Since it takes 50 seconds to get 1 pristine witch matter, and each 1 pristine witch matter makes 16 redstone, that's basically 16 redstone every 50 seconds, so to get 60 redstone takes even longer. So this is, like, horrible. We need so many models in order to get even a reasonable quantity of chrome. So why in heavens am I doing this? It's because I want an HV macerator, which requires some stainless steel, in order to maximize the amount of ruby dust and chrome dust that I get from processing ruby ore, because to get ruby ore, I'm going to need omnicoins, and guess who doesn't have an enormous amount of omnicoins? This guy. Maybe at some point I'll do some crazy automation to create most of the items for these bounties so I can get lots of omnicoins so I don't have to feel starved every time I grab rubies. But the path I'm probably going to go is to get exquisite rubies from Tier 3 microminers and gemstone sensors. And I know this is going to be crazy because to get a gemstone sensor I need things like tungsten carbide and particularly Tier 5 circuits. And the way to get the particular Tier 5 circuit I need is, well, it's a bit silly. As you can tell, there's a lot of absurd things that I'm doing in order to get it. But it will get me automatic ruby dust so I can get lots of chrome. And that is what I want to do. But eventually, that'll take a while, so let's not think about that right now because it's really scary. Anyway, I made tons and tons of things, and I'm still not even finished making all the things I need for this episode because what we're going to do is make a system to process oil. So it's going to be a petrochem system. And the reason for that is the long-term goal of getting microcircuits, which is the best form of the Tier 2 circuits. Why? Because you need epoxy circuit boards, and what you need to get epoxy circuit boards, you need epoxid, which you can get from epoxy resin. And epoxy resin requires several things. Either an enormous amount of fish oil, if fish oil is like the worst possible route you can take, or you can use petrochem to get it better. You can also do canola farms, but I don't want to do farms. So petrochem is probably the best way to go for me right now, and it is technically free because it pulls oil up from the void, the yawning void. So that's what we're going to try and do. But yes, before petrochem, we have a project which is to get lots and lots of chrome for stainless steel because I want to make distillation towers. And distillation towers are enormous multi-blocks involving lots and lots and lots of stainless steel. And I'm going to need about 2 of these. However, they won't be as tall as you think they are. To get the macerator, I need about 16 stainless steel, and so to get all that, I'm cooking up 2 pieces of chrome because 1 piece of chrome converts to 9 stainless steel dust. You can get manganese dust from several sources, but the cheapest in terms of omnicoins is pyrolusite ore. One benefit of having an HV macerator is that these things will go faster. In order to preserve even more stainless steel, what I'm going to do is to power the HV macerator, I will hook up 2 energetic alloy wires to it and use this CEF because I am not smart. In other news, here's 6 ruby dust quickly to be electrolyzed into chrome dust. Beautiful chrome dust. And now I'm electrolyzing 3 pyrolusite dust into my manganese. And boom, my very first stainless steel dust, which I will now blast furnace into stainless steel. 1 diamond grinding head, billions of other things to go, such as the first tier 3 circuit yet again, which I'm going to make using all these methods. Now, however, I will use SMD. And I'm just going to shove 32 silicon wafers into this advanced precision laser engraver, so I get so many ways to get integrated circuits, because I'm probably going to need a couple of these, and by a couple of these I mean like 10 or 12, so I'll want a lot of these integrated circuits. Now is the perfect time to show off my cutting machine, now full of lubricant. Lubricant is a great fluid made best from oil and redstone, and oil, even though I don't have the oil drilling rig yet, you can get from electrolyzing oil sands dust, and you can get oil sands dust from oil sand ore, which you can buy with omnicoins. Pro tip, 30 oil sand dust plus 40 redstone is the precise amount to make 30 buckets of lubricant. Anyway, the cutting machine is really fast when using lubricant. 1 HV machine hole. I don't understand why they haven't given me this quest already. I have made so many numismatic dynamos and laboratory calibration units. Could someone please tell me why I'm using polyethylene sheets for plastic circuit boards when it's literally more efficient to use polyvinyl chloride sheets? Excuse me, give me 1 second. I'm going to fix this problem right now. There, oh my gosh, that's about like 5 billion times better. No wonder it was taking so long to make plastic circuit boards. I could have made them like Anyway, small stainless steel gears are made as such. 2 electric motors, an electric piston. These used to be dreadfully slow in the cutting machine, now with lubricant they are slightly less dreadfully slow. And finally, 5 minutes into the video, our universal macerator. Behold the monstrosity. And now, to use 4 omni nickels to make 32 ruby ore, and then chew it up in the universal macerator, hopefully reasonably quickly, and get all that tasty chrome dust. Now, why did I get an HV macerator as opposed to an MV macerator? The HV macerator has 3 slots. The MV macerator only has 2. Most ores when macerated result in 3 different compounds, one of which is pretty much useless, and so those stone dusts might have actually taken up the pulverization slots. However, I want to always have a possibility of getting chrome. I want to maximize that possibility. And now, to electrolyze most of my ruby dust into lots and lots of chrome, but the real place that I got enormous amounts of chrome is here. Those 32 pieces of ruby ore ended up getting me a whole 28 chrome dust, and these 10 extra pieces of chrome dust are just going to be a bonus. And now to excitedly crush pyrolusite ore into lots and lots of manganese dust so that I can make lots and lots and lots and lots and lots of stainless steel. Am I making 8 wire cutters for reasons? Yes, I am. Anyway, we have 2 big projects that I need to get a bunch of stuff for, one of which you won't see anything done at all, except for the pipe for the oil drilling rig, which requires a small steel pipe, for which you need an extruder, but I already have an extruder right here, But there's also the distillation tower, which I now need to explain at length. Let's talk about distilling oil. Let's press U-shoes on oil to look at the distillation tower. This creates 4 fluids. The distillation tower changes its height, or you change its height, based on the number of fluids you want to come out of it. Since we only need 4 fluids, we need a distillation tower of height 5. The naphtha and the heavy fuel are eventually going to get distilled, and I'll explain that process, into all of these items, so I'm going to need a 12 tall distillation tower. But once we distill things like naphtha and heavy fuel, we'll get this useful propene, which I can turn into allyl chloride, which is one of the steps for epichlorohydrin. And then I can either use naphtha or bisphenol A to make epoxy resin. Naphtha, I'm supposed to be using naphtha for other things, so I'm probably going to use bisphenol A, but let me check real quick to decide. I'll tell you guys once we do epoxy resin whether we're going to be using bisphenol A or naphtha. For a distillation tower, most of the layers look the same except for the bottom layer, and so I'm going to need 11 quote-unquote top layers for the distillation tower 1 and 4 top layers for the distillation tower 2. Anyway, the math works out to needing 117 clean stainless steel casings, which means I'm going to need about 289 stainless steel to make all the stainless steel casings. Now that is 17 squared. To get the pipes required to make the distillation tower, which are 4 large stainless steel pipes and some medium stainless steel pipes, only an extra 30 stainless steel, so I end up needing 319 stainless steel, which roughly equates to 35.4 chrome dust. And I have so much chrome dust that this is not a problem. Here goes all the stainless steel in the world, time to cook it extremely slowly in my blast furnace. In order to save on stainless steel, since I need to make lots of HV machine holes, which is going to be more than the 319 stainless steel I told you I need to do, I'm going to want to create HV machine holes using casings and the polyethylene recipe. But I have so much extra polyethylene for the first time ever, where is it, that I am very happy to just grab 64 of it all at once. And then just shove it into this assembling machine so that I can start making them easier. It's taking forever to make stainless steel with this blast furnace, and I have so much, so I'm going to switch it to HV. For that, you need the lossless cable of vibrant alloy. So we'll use the HVC, the HV machine hole recipe for the first time after we make our HV machine casings. We'll make 2 HV energy input hatches, and with the 16 electronic processor arrays I just made, which were 3 stacks worth of electronic circuits, I will make my first HVCF. Exciting! It's 2.8 times faster now, and it is so much better. To make the 40 stainless steel frames I'm going to need 50 stainless steel rods and 30 stainless steel plates. The 117 casings will also require 234 stainless steel plates, which is, according to my calculations, 26 blocks worth. So once I have 26 blocks of stainless steel ingots, we'll start the cutting saw. I figured out where all of my gallium dust went. Apparently the system I made to stop the machines from running wasn't timed perfectly, as when a gallium ingot would be compressing, the furnace in the packager would run much faster. So I wasted a lot of gallium this way. Well, I didn't waste it, it's just in the form of gallium dust, which is useless to me. So my current plan to fix this is to set a limited item filter, putting 1 gallium dust into this electric furnace, to turn off auto output for the packager, and then to remove all of these gallium dust and just put 1 in. And I'll set right here, this is going to be on extract always active. That way we'll get only 1 gallium dust, and the backlog we build will be at max 64 gallium dust. 26 blocks of stainless steel. Now to use a large pipe shape to make 4 large stainless steel pipes, and then I'll use an extra 3 with a normal pipe to make or an extra 6 to make the extra medium stainless steel pipes I need. And now, with 39 stainless steel frames and 234 stainless steel plates, I will now proceed to make all of my casings. Excuse me, I'm going to stop right now. I forgot to tell you guys, and I also forgot myself, that you can combine the walls of distillation towers, just like with blast furnaces, much more efficiently to reduce the amount of stainless steel casings you actually need. So I did not need all this stainless steel. Luckily, I now have it. Turns out I only needed 102 casings. This is 28 steel frames, so to make sure my numbers are correct, I'll shove all those in here and hope it works out. I am now what is colloquially called a happy spirit. Behold, 2 distillation towers, how exciting! 15 buckets for the 15 LV fluid output hatches, and then I'll do 2 more for the inputs. Oh, I did not need all those buckets, I actually just needed glass. Why didn't anyone tell me? I don't know if I accidentally made an incorrect video saying that you need HV power, but you only need MV power to power distillation towers. I'll put my 2 MV energy input hatches right here and then set them all to be facing downward. And then the 2 fluid input hatches need to be in the exact center of the multi-block, so again I'll make these face downward. I think that I'll place my 2 output buses in the back here for easy access. And then here are the control blocks for the 2 distillation powers. Before I fill this in, I'm actually going to put down my ender fluid conduits, and I'm going to filter them on the relevant fluids, just so that I don't have to reach down under afterwards. On the left input hatch, I'm going to input oil, and I believe it's this kind of oil. And on the right, I'll filter steam cracked naphtha. And cracked heavy fuel, which will also be going into this distillation tower, but you'll find out more about that in the petrochem episode. And then the 4 shared walls. And then the 4 and the 11 output hatches. This multi-block is hollow in the center until you reach the top, so as we fill this in, when we get to the very top, we'll make a solid cover. Behold, 1 tower done. And with exactly perfect calculations, my final casing goes here, and I get my other enormously tall distillation tower. Wow, the answer is just wow. I decided to give them little hats. In 12 minutes, you all have seen the fruits of a 2.5-hour endeavor. However, petrochem is still a big boy, and we have so much to do to get petrochem up and running, so that's going to be in a second episode. Hopefully it doesn't end up being a third, but I know that if I make this into one single episode, it'll go over 20 minutes, which we've already done once, and I'm not doing that again. But as a quick hint into what we will be doing, the hope is to distill oil into sulfuric naphtha, and then hydrodesulfurize the naphtha, and then break it up into, using steam, into steam cracked naphtha and distillation tower that again. At the same time, we'll be mixing our heavy and light fuel into diesel, and eventually turning that into nitro diesel. And I think those are the main things we'll be doing. If I want, I'll make tetranitromethane, but ethanol requires acetic acid and sulfuric acid. It'll be a little bit before we get that, but as soon as we make epoxy resin, we'll be able to do that, so that's very exciting. Anyway, so much cool stuff happening. It's all going to be awesome and great, and I'm very excited to show you guys the wonders of petrochem, which I've actually never done until this set of videos. So I will see you guys in that set of videos. But anyway, that's it for today's episode. As always, if you have any feedback, I would love to hear it. I hope you enjoyed, and God bless you all.